Hi and welcome to this lesson. So we're on page 35. Let me just get my pen working here. Page 35 of your blue book. The picture here is what I've got set up in, behind the computer, and I'll show you in a second. I've got a ramp. Here's my ramp and a cart that can roll down it. I start the cart at the top and let go, and it rolls down. So I guess I'll show you that first. So let's go around. You can see my trusty banana holding the cart. I remove the banana. He rolls down. Right, so that's what I've got set up. The first job you've got is to draw a motion map of the cart's motion along the ramp, and I'm going to do this first one for you. As we go on, you're going to do more of them yourself. So it says to include a velocity and acceleration vectors. Let's just make this nice and thick. So what I'm going to do is with different colors, I'm going to do my velocity and acceleration vectors. There we go. And I always like to draw the dots first. So with this guy, I saw him speeding up. So the dots are getting further and further apart. And I don't know what happened to my dot in there. I then draw, come back, then draw an arrow on each one, and that is representing the velocity. Now that velocity each time, each second, is getting larger. So my arrows get larger. And above each of these, I put a V for velocity. And the reason I do that is because we're now going to have velocity vectors and acceleration vectors. So then I'm going to do my acceleration maybe in a different color. I don't have room here, so I'm just going to do it underneath the measuring tape. It doesn't matter where you do it. But my acceleration vectors are always in between my velocity vectors. So that's in between, and I put an A on it. Now, what this is if I take this and I add my acceleration, I'll get my next velocity. So for the next one, if I have this velocity and I add an acceleration vector, that's how I get my next velocity. So the acceleration is always the difference between two velocity vectors. Here's another acceleration. Here's another acceleration. Now, importantly, these acceleration vectors are all the same size. And they're all in the same direction. So in this case, is my velocity positive or negative? Here's my positive down here. And my velocities are going in the same direction, so my velocity is positive. Is my acceleration positive or negative? My acceleration is in the same direction as my positive again, so my acceleration is positive. Okay, the next part of this page, predict the graphs describing the motion. Your job is to predict a position graph, a velocity graph, and an acceleration graph. So what I'm going to get you to do is I would like you to pause the video when I've finished talking and have a go in your book at predicting. So pause now. Okay, right, we're back. You've paused, you've made a prediction. It's really important that you actually make your own prediction. If you just watch this video, it will make sense now, but you won't remember it. Making the prediction and either being wrong or right, but actually putting pen to paper will make sure you learn. Let's actually see what happens when we do the experiment. So you saw it before. I want to get my logger pro going. I'm going to zero it so it knows where it is as 0. I've got it set up to trigger, so when I start the collection, it doesn't start until I remove the banana. So here we go. All right, and the other thing is we can quickly zoom in on these, auto scale from 0 and auto scale from 0. So there's my position time graph. It looks like it's a curve because it's accelerating. My velocity time graph looks like it's a straight line that it's increasing the same amount each second. And my acceleration graph is positive and it's a straight line just above the 0 mark. So in my actual data here, it looks like I had this. Oh, go away. I had this, and I had a horizontal line. Right, I would like you to pause the video when I finish this sentence and answer G and H, and I'll go through them as soon as you have. So pause now. Okay, so you've had a go at answering those. The slope of my position time graph, it gets steeper. I mean, it's not very steep here, but it gets really steep up here. So the slope's increasing, and it's definitely a positive slope, and this represents the velocity. The slope of my velocity time graph, it's the same slope all the way up. It's a constant slope, it's positive, and it represents the acceleration. Okay, so tune in for the next video and we'll look at page 36.